NEC 250.142b addresses the use of the grounded conductor for grounding equipment on the supply side of the service or on the supply side of a separately derived system. This is a critical section of the National Electrical Code that outlines specific requirements and exceptions for grounding practices, particularly concerning feeders and meter enclosures. Under the 2005 NEC 250.142b requires that feeders be installed in a raceway or cable extending from the service equipment directly to the panel board. This means the feeder conductors must be enclosed in a metallic raceway, such as electrical metallic tubing or EMT, rigid metal conduit or RMC, intermediate metal conduit or IMC, or in a cable assembly with a metallic sheath, like armored cable or AC, or metal-clad cable or MC. The purpose of this requirement is to provide a continuous, low-impedance ground fault current path back to the source, which facilitates the operation of overcurrent protective devices like circuit breakers and fuses in the event of a ground fault. Exception 2 of 250.142b allows for a feeder disconnect to be located in the same enclosure as the service disconnecting means. However, the key point of contention often arises with the interpretation of what constitutes being immediately adjacent to the service equipment. This exception does not extend to meter enclosures that are not considered immediately adjacent to the service equipment. In the context of the NEC, immediately adjacent is interpreted strictly. Meter enclosures that are physically separated from the service equipment, even if by a short distance, are generally not considered immediately adjacent. The code emphasizes a direct connection without intervening components or enclosures. Regarding meter enclosures, it's important to recognize that they are not typically considered part of the service equipment. They are separate enclosures that house the metering equipment used to measure electrical consumption. Because of this separation, the rules governing service equipment do not automatically apply to meter enclosures, especially when it comes to grounding and bonding. To comply with NEC 250.142b when meter enclosures are involved, the feeder must still be installed in a raceway or cable that extends from the service equipment to the panel board, and the meter enclosures must be properly grounded and bonded according to the applicable requirements in Article 250. This typically involves running a separate equipment grounding conductor or EGC from the service equipment to the meter enclosure to provide a low impedance ground fault current path. Now let's consider meter enclosures with isolated socket connections. These types of enclosures are specifically designed to address the requirements of NEC 250.142b and allow for the installation of meters outside the service equipment enclosure, while still maintaining compliance with the code. These enclosures feature a non-metallic barrier between the socket connections and the enclosure itself. This barrier serves to isolate the meter socket from the metallic enclosure, preventing the enclosure from becoming energized in the event of a fault. The design of these enclosures allows for the equipment grounding conductor to be connected directly to the meter socket, providing a direct ground fault current path back to the service equipment. This ensures that any fault current will flow back to the source, tripping the overcurrent protective device and energizing the circuit. When using meter enclosures with isolated socket connections, it is essential to follow the manufacturer's instructions and the applicable requirements in NEC Article 250 to ensure proper grounding and bonding. This includes properly sizing the equipment grounding conductor, making sure that all connections are tight and secure, and verifying that the installation meets all applicable local codes and regulations. It is also important to ensure that the meter enclosures themselves are listed and labeled for the intended purpose and are installed in accordance with the manufacturer's instructions. This will help to ensure that the enclosures are safe and reliable and that they will perform as intended in the event of a fault. Now let's address the use of wireways in these installations. When a wireway is used between the service equipment and the meter enclosures, it must be listed for the purpose and installed in accordance with NEC Article 376 for metal wireways and Article 378 for non-metallic wireways. A wireway is a sheet metal trough used to protect and route electrical wires and cables. It can be either metallic or non-metallic and is typically used in exposed locations where the wiring is accessible for maintenance and modifications. The NEC specifies requirements for the construction, installation, and use of wireways to ensure that they are safe and reliable. These requirements cover things like the materials used to construct the wireway, the methods used to support and secure the wireway, the types of wiring that are permitted in the wireway, and the clearances that must be maintained around the wireway. When installing a wireway, it is important to follow the manufacturer's instructions and the applicable requirements in the NEC. This will help to ensure that the wireway is properly installed and that it will provide adequate protection for the wiring. Taps from the wireway to the meter enclosures must be properly supported and protected. The NEC requires that all electrical conductors be properly supported and protected to prevent physical damage and to ensure that they are not subjected to excessive strain or stress. This includes the taps from the wireway to the meter enclosures. The taps must be supported in a manner that prevents them from sagging or becoming damaged. They must also be protected from physical damage, such as abrasion or impact. One common method of supporting and protecting taps is to use cable ties or straps to secure them to the wireway or to other nearby structures. Another method is to use conduit or tubing to enclose the taps and protect them from damage. The specific method used will depend on the type of wiring, the location of the taps, and the applicable requirements in the NEC. The meter enclosures themselves must be listed and installed in accordance with NEC 250.142 and any applicable local codes. Listing means that the meter enclosure has been tested and certified by a recognized testing laboratory such as Underwriters Laboratories or UL to meet certain safety standards. The listing mark on the enclosure indicates that it has been evaluated and found to be safe for its intended use. Installation must be in accordance with NEC 250.142, which specifies the requirements for grounding and bonding meter enclosures. This includes ensuring that the enclosure is properly grounded to the building's grounding electrode system and that all metallic parts of the enclosure are bonded together to create a low impedance ground fault current path. In addition to the NEC, local codes may also have specific requirements for the installation of meter enclosures. These requirements may vary depending on the jurisdiction and the specific application. It is important to check with the local electrical inspector to determine what codes and regulations apply to the project. Now let's talk about some additional considerations when working with NEC 250.142. Firstly, it's essential to understand the definition of service equipment. The service equipment includes the main disconnect, overcurrent protection, and any other equipment used to control and protect the electrical service to a building. The location of the service equipment is critical because it is the starting point for the feeder that supplies power to the panel board. Secondly, the equipment grounding conductor or EGC plays a crucial role in providing a low impedance path for fault current to return to the source. The EGC must be properly sized and installed to ensure that it can safely carry the maximum fault current that may occur. Thirdly, bonding is the process of connecting all metallic parts of the electrical system together to create a continuous electrical path. Bonding is essential for minimizing voltage differences between different parts of the system and for providing a low impedance path for fault current to flow. Fourthly, local codes and regulations may have additional requirements for the installation of meter enclosures and the grounding and bonding of electrical systems. It is important to check with the local electrical inspector to determine what codes and regulations apply to the project. Fifthly, proper documentation is essential for demonstrating compliance with the NEC and other applicable codes and regulations. This includes providing detailed drawings, specifications, and calculations to show that the electrical system has been designed and installed in accordance with all applicable requirements. Sixthly, the importance of using qualified personnel cannot be overstated. Electrical work should only be performed by qualified electricians who are trained and experienced in the installation and maintenance of electrical systems. Qualified electricians have the knowledge and skills necessary to safely and effectively install and maintain electrical systems, and they can help to ensure that the system complies with all applicable codes and regulations. Lastly, regular inspections and maintenance are essential for ensuring the ongoing safety and reliability of the electrical system. Electrical systems should be inspected regularly to identify any potential problems, and maintenance should be performed as needed to keep the system in good working order. Regular inspections and maintenance can help to prevent electrical fires, shocks, and other hazards. In summary, NEC 250.142b requires that feeders be installed in a raceway or cable extending from the service equipment directly to the panel board. Exception 2 allows for a feeder disconnect in the same enclosure as the service disconnecting means, but meter enclosures are not typically considered immediately adjacent to the service equipment. Meter enclosures with isolated socket connections are available and designed to meet the requirements of NEC 250.142b. When installing meter enclosures, it is important to follow the manufacturer's instructions and the applicable requirements in the NEC and any local codes. Wireways used in these installations must be listed for the purpose and installed in accordance with NEC Article 376 or 378, and the taps from the wireway to the meter enclosures must be properly supported and protected. By following these guidelines, you can ensure that your electrical installations are safe, reliable, and compliant with the NEC. Remember to always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements.